My name's Jeff Cady, and I'm going to show you how to set up the AU Physics Enterprises Diffusion Cloud Chamber so you can see radiation interacting with matter for demonstration purposes.
I'm going to take you through the setup of the cloud chamber. This is a commercial-based cloud chamber that uses a solid-state cooling device. It uses ice water instead of dry ice. But if you don't set it up correctly, you can burn up the unit and it won't work. So I want to take you through a quick how you set this up and so you can use it. So come over here for a second. And in here is just a cooler. This is where I'm gonna have some ice water, and this is just an aquarium pump. Okay, so you want that on the bottom first, and then you're gonna put just a little bit of water in. You know, you don't need too much because I'm about to add a bunch of ice to it. So, okay, so that's the first thing. Now the aquarium pump is in there. It's got enough water to cover it, and it's going to melt. It melts over the use of it. On the back of this, we put in a tube that goes in. Either side doesn't matter, but you need a return because it's going to pump the water in, and we want the water to go back to our reservoir. So we'll put that back in to the cooler. It doesn't have to be a cooler, but over the course of hours, the condensation and whatnot is a bit of a pain, so I like to use a cooler. It minimizes that overall effect. Okay, so now I'm going to plug in that aquarium pump so we can get the water flowing through there. And you really need the water to flow before you turn this unit on, or else you can burn up the cooling unit. All right, so I have the cooler with the ice bath in it, just a little bit of water, and then you can see, so I have the water pumping into one side of the plate and coming back out, and I'm returning it to the ice bath. Okay. Over the course of the day, if I'm doing a merit badge session or a Girl Scout session, something where I'm going to be there for 6 to 8 hours, I'll bring 3 or 4 bags of ice, so the larger bags of ice, into a large cooler and then just replenish it throughout the day. But you always want to make sure that water's flowing through here. So now I've got the water flowing and this cold plate is starting to cool off, and I'm going to add isopropyl alcohol. Can you get inside of here real quick? So here's what's inside of the chamber. You can see there's some LEDs here. Okay, and when we turn that on, those will shine bright. There's cutouts here in this blotter paper. Oh, you're fine. And those are going to be situated where the LEDs are. So I'm going to get this in, and I'm going to use the 91% isopropyl alcohol. Don't use the 70. If you use the 70, it's not going to work. You need the higher grade isopropyl alcohol. So we're going to use the 91%, and you don't need all that much, like a milliliter or two, or I'm sorry, a millimeter or two along the bottom. And then I'm just going to use this dropper to soak the blotter paper. Okay, so I have the blotter paper soaked with the 91% isopropyl alcohol, and I have the blotter paper arranged so that the LEDs will be able to show when I turn this on. And I'm going to put the cover on now so that the alcohol vapors can start to saturate inside of that environment. So I'm now going to plug in, and if you look at the front here, this is where the power supply goes into it. And then I'm going to plug this into the extension cord here. And then if you look inside of here, you can now see the lights, the LEDs are shining. Okay. Last thing we need to do, we want this to all stabilize. So I'm going to enter the source here. And what we have to do now is wait about 20 to 30 minutes, and then we'll start to see the clouds form inside of here. Okay, this has been going for, I don't know, a little over 20, 30 minutes. All right, I got busy. It's been more like an hour. But you can see inside that we're getting the tracks inside of there. Let's see if we can get that more clear. clear or not. But clearly getting good indications inside of here. So thoriated tungsten welding electrode is what I use for the source. This is supposed to it's a really high ohm resistor that's supposed to sweep the ionic field away, according to the manual.
Here's the quick rundown. The cold plate on the bottom is cooled to about negative 35 degrees centigrade inside of that chamber. The ice water is actually the warm side of that plate. It's where the heat is being rejected to as the ice water. There's alcohol sitting on top of that cold plate, but it's wicking up the sides of the blotter paper, creating an alcohol vapor throughout the chamber volume. Down near the plate, it's a super saturated solution. There's more alcohol there than it would normally be able to hold. Radiation ionizes the atoms inside of the chamber, and that alcohol vapor condenses on the ionized atoms, and that's what makes the little cloud formations, and you can watch it rain back down to the bottom, and the process just go over and over and over.
So another thing is the ice water. You can see a lot of the ice has already melted away, so you want to make sure that you replenish the ice. If it gets too warm, the thing will stop working. So check your ice throughout the day.
A note or two on getting the clouds to show. When you purchase the unit, it doesn't come with a radioactive source. It just has this stopper, this gum rubber stopper with a piece of bar stock on there. And you would then use like cosmic rays and to try and see the tracks as they go through there. And then you don't see them very often. So it lasts, a child's attention span doesn't quite go that long, and most adults either. So you can use a source. Now you could purchase sources that go along with it. Here's one that's a strontium-90 source, and so that one's still around because it has a longer half-life. But if you buy the one for the alpha particles, polonium-210 doesn't last all that long. This was back, this is 7 years ago, so 138 half-life, 138-day half-life. This one is pretty much gone. It's just a needle that they've deposited some radioactivity at the very end, the very tip of it. What I prefer to use is a thoriated tungsten welding rod. So this is for tungsten inert gas welding. The electrodes, I've basically just taken the gum rubber stopper, drilled it out, and was able to shove one of those through. That has 2% thorium in it, and that thorium is giving off radiation at all times. So using that as your electrode in there, or your source, gives you a nice regular and routine display of particles. So recommend using that. Well, whether you're borrowing mine or buying your own, good luck to you, and I hope you have fun doing demonstrations with the people.